Lesson 5-7, changing decimal divisors to whole numbers. Now that's a mouthful, but basically in this lesson, we're going to be looking at division problems where instead of the divisor being a whole number, the divisor, which is the number outside or to the left of the bracket, is going to be a decimal. And we need to do some upfront steps to clear that decimal point out, rewrite it as a whole number before we can get into the business of solving it using division. Let's take a look at the odd numbered problems only and get started. Number 1, Tyra has 6 hours to study for a test. She plans to do a quick review of the material she reads every 25 hundredths of an hour as she works, or quarter of an hour as she works. How many times will she stop to review during her study session? Okay, so first, as with any word problem, make sure you really understand and can visualize the situation. This student, Tyra, is planning to spend 6 hours studying for a test, but in the course of those 6 hours, she's going to pause every quarter of an hour to review her notes instead of just going straight through 6 hours with no pause or break. So she's going to take a little review break every quarter of an hour. How many of these review breaks or stops is she going to take during this 6-hour study session? So we're really taking this amount of time, 6 hours, and dividing it up into sections or chunks of 25 hundredths of an hour. So let's write that out as long division here. You'll see that, as promised, the divisor has a decimal point in it, and in this case, the dividend does not. What we need to do is we need to count how many places there are for us to push this decimal point and clear it. Whoop, whoop. Did you count 2 pushes? Now we have to do the same thing to the dividend. As with equivalent fractions, what we do to the bottom, we do to the top. Here, what we do to one side, we've got to do to the other. So if I made 2 pushes this way, which is kind of like multiplying this by 100, I've got to do 2 pushes here as well. I'm going to imagine a decimal point, 2 pushes, whoop, whoop. And so this decimal point would appear here, and in these placeholder spots, we'd insert zeros. Now, let's just rewrite this. Whoop, whoop. The new divisor is 25. Whoop, whoop. And the new dividend is 600. Now, you might be asking yourself, well, hold on. This is a completely different problem than the numbers that we're given with here. How can solving this allow us to get an accurate answer for this when the numbers aren't the same? And if you're thinking that, I'm glad you are. I want to show this to you using fractions to help you understand why this works. Remember, when I express something using division, whether it's something as basic as, oh, how about this? I think you can do this as mental math. We'd say this is 12 divided by 4. I think you know what 12 divided by 4 is. But I think you would also agree that I can express this as a fraction with my dividend, or the number that's being divided, on top is my numerator, and the divisor, or how many ways I'm sharing or splitting it, being my denominator. Now, let's see this in action using these numbers. 6 was my original dividend, and 25 hundredths was my original denominator. Remember, with fractions, with equivalent fractions, what we do to one side, we must do to the other. So in this case, I needed to push a decimal point out 2 places to the right, whoop, whoop, to change this into a whole number, which is like multiplying this by 100. So if I'm going to multiply the divisor by 100, I've got to do the same to the dividend. Clearly, 100 over 100 is 1 whole. So I'm not changing the value of this original fraction in any way. I'm just rewriting it as an equivalent expression. 6 times 100, of course, is 600. And 25 hundredths times 100, well, there's 2 zeros here. So whoop, whoop, 2 pushes to the right. Now, that's why we can do what we're doing, because this division expression is equivalent or equal to this division expression. Let's get back into the business of performing division. Now that we've done this upfront work of rewriting the divisor, which was a decimal, as a whole number, we can go ahead and perform division. How many times does 25 go into 60? 2 times. 25 multiplied by 2, 50. Subtract that out. Do my bring down. The new number that's formed is 100. 25 goes into 100 4 times. 25 times 4 is 100. After we subtract, there's nothing left over. There's nothing to bring down. We have our answer. She's going to take 24 stops during the study session. Moving on to number 3. A centimeter is 1/100th of a meter. If a building is 9 meters wide, how many centimeters wide is it? Okay, so we're taking this amount and we are dividing it into smaller units of 1/100th. So let's write that out. Now look at your divisor, which is a decimal. How many places do we need to push the decimal point to clear it out and rewrite the divisor as a whole number? Whoop, whoop. 2 pushes. What we do to one side, we must do to the other. So imagine that invisible decimal point here. Whoop, whoop. Now let's rewrite this with a divisor that's a whole number. What's 900 divided by 1? I think you know. 1 goes into 9 9 times. Multiply that out. Bring down your 0. 1 goes into 0 0 times. Multiply that out. Bring down your 0. 1 goes into 0 0 times. 900. 900 centimeters. And this makes sense, doesn't it? We can think about it in terms of multiplication as well. A meter stick is 1 meter long and 100 centimeters long. So 9 meter sticks back to back would be 9 times 100 or 900. Number 5, Clarissa is buying pencils at 65 cents each. She spent $12.35 on the pencils. How many did she buy? Let's take the total amount she spent and divide it by the cost of each pencil. Looking at the divisor, which has a decimal point in it, how many places do we need to push the decimal point to clear it out? Whoop, whoop. 2 pushes. What we do to the one side, we do to the other. Whoop, whoop. And let's rewrite this. Now our divisor is a whole number, 65, and our dividend is 1,235. 65 is close to 70. 70 goes into 123 once. So I think what we're looking at here is going to be a 1 or a 2. 65 times 1 is obviously 65. 65 multiplied by 2, let's do a side calculation. 2 times 5 is 10. 0 comes down, carry the 1. 2 times 6 is 12 plus 1, 13. 2's out. 130 is too high, so we're going with 1. 65 multiplied by 1 is 65. Let's subtract. 3 needs to borrow. 13 minus 5 is 8. The 1 now needs to borrow. 11 minus 6 is 5. And we bring down. Now again, 65 is close to 70. 70 goes into 585 about 8 times. Let's test out 8. I'm thinking it's going to be an 8 or a 9 up here. 65 times 8. 8 times 5 is 40. 0 comes down, 4 goes up. 8 times 6 is 48 plus the 4 is 520. That works. But I'm looking at this, and I can see if I add another 65 here, I'm going to get 585 exactly. So it is 65 times 9. Because 65 times 9 is going to be exactly 585. And our answer is she bought 19 pencils. Number 7. How many places do we need to push the decimal point to clear it out? Whoop, whoop. 2 places or 2 pushes. Same here. Whoop, whoop. So our new divisor is 6. Our new dividend is 3,000. You can certainly rewrite that if that's less messy for you. Let's find how many times 6 goes into 30. 5 times. 6 times 5 is 30. Subtract, bring down. 6 goes into 0, 0 times. Multiply, subtract, bring down. Again, 6 goes into 0, 0 times. Multiply, subtract. Nothing left to bring down, nothing left over. Our answer is 500. 360 divided by 4/10. Let's make one push to rewrite this as 4. And we'll do the same over here. One push means I'm basically adding a 0 here to make that 3,600. Now 4 goes into 36 9 times. 4 multiplied by 9 is 36. Subtract, bring down. 4 goes into 0 0 times. 4 multiplied by 0 is 0. Subtract, bring down. Again, 4 goes into 0 0 times. 4 multiplied by 0 is 0. And nothing to bring down and nothing left over. Number 11, 336 divided by 8/10. How many pushes will do the trick here? Whoop, one push makes the divisor 8. One push makes the dividend 3,360. Let's find 8 goes into 33 4 times. 8 multiplied by 4, 32. Let's subtract and bring down. Find 8 goes into 16 twice. 8 multiplied by 2 is 16. Let's subtract. Let's bring down. Let's find 8 goes into 0 0 times. 8 multiplied by 0 is 0. There's nothing left to bring down, nothing left over. Our answer is 420. And 13, 595 and 84 hundredths divided by 56 hundredths. How many places do we need to push the decimal point? Whoop, whoop. 2 pushes. And we can rethink or rewrite our divisor as 56. What we do to that side, we'll do to this side. Whoop, whoop. And the dividend becomes 59,584. And let's get going. Let's find 56 goes into 59 once. 56 multiplied by 1 is 56. Let's subtract and bring down. 56 goes into 35 0 times. Let's multiply, subtract, bring down. Now we have to find 56 goes into 358. Well, 56 is close to 60. 60 times 6 is 360, very close. So I'm going to test out multiplying this by 6 as a side calculation. That feels like that's going to get me real close. 6 times 6 is 36. 6 comes down, 3 gets carried. 6 times 5 is 30 plus the 3. And that checks out. And 336. Let's subtract. Let's bring down. 56, again, is close to 60. 60 goes into 60 times 3 is 180. 60 times 4 is 240. I'm gonna test out multiplying by 4. I've got a good feeling about that. 4 times 6 is 24. 4 comes down, 2 gets carried. 4 times 5 is 20 plus the 2. All right. And we got our answer, 1064.